Good morning and welcome. Charlie, can you turn on your camera? There he is. Welcome to CITM and the Innovation Factory and our webinar today on V2X. Just a few seconds on CITM if you don't know. CITM is one of the AVEN, or Autonomous Vehicle Innovation Network, which is Ontario's Connected and Autonomous Vehicle Program. We're one of the regional development sites in Hamilton, Ontario. We build and maintain smart infrastructure networks, right, to enable startups and scale-ups to test their solutions in a real-world environment. Part of the hardware that is on our networks is V2X equipment that is supplied by our iSmartways. Right? And here to give us the story on V2X and why it's important and how it will continue to be even more important over time is Charlie Chen. Charlie,
hi.
Can you a little bit on who you are and what you do at iSmartways, and then you head into your presentation.
Sure. Thank you, Richard, for the opportunity. My name is Charlie Chang. I am the Business Development Manager for iSmartways. I'm actually based in Detroit, Michigan, so just across the river here in between Canada and the US. And I previously worked a lot in the automotive industry. Naturally, also, I grew up with a automotive family, tier 1 supplier, manufacturing, OEMs, etc. And then as the big topic of self-driving came to place, I also did a lot of work with test beds and test tracks and vehicle testing as it relates to connected autonomous, also electrification. And I've recently joined iSmartways to tackle this really interesting topic of machine-to-machine communication. Pleasure and look forward to it. Should I share slides now? Can you see this?
Yep, you're good to go.
Perfect. Thank you. And I'll try to talk a little slow, and if there are connection issues, please let me know. This is very excited to present this. I think where the state of the industry is at right now shows a lot of kind of how daunting the task is to really deploy connected autonomous vehicles, and also justifies kind of why places like CITM and Innovation Factory are so important to kind of this industry and in the development mode, let's say. So I first like to start off with, kind of what V2X and what did it actually do to this world. Compared to the other generations, 3G, 4G, a lot of the network and the wireless broadband was targeted towards the end user, like our everyday phones, smartphones, etc. But the ongoing rollout of 5G and the new side of the wireless is really focused towards transportation and mobility, so the industry sectors. And that brings a host of other challenges that very different from end users. And they've now allocated an unlicensed spectrum, which has been a lot of debate right now in the government side in the US at least, that allows terminals to communicate in the short range without a SIM card. And then there's obviously the licensed spectrum that has been already used right now by OEMs, what we call the V2N, vehicle to network. And these are obviously, terminals or roadside devices or vehicles or any kind of device in that can communicate, wishing to use short or long range communication. Obviously, that will then depend on how the spectrum, who owns the spectrum, and how they're keeping track of users, etc. So this is currently the growing environment for what we call, what we say is really machine-to-machine communication. And those terms in the V2X and the M2M are all could get a little confusing. But I prefer to say that this kind of technology really brings forth a new environment for the movement of goods and people. And this will change things forever, because just like as the smartphone did with information, right? And so this is why I also say, why is V2X? It obviously utilizes the same technology that really powered the communication in the smartphones and really allowed unlimited mobile access, whether that, the information, whether or not that unlimited access is good or bad. But also now enables a lot of the new automated driving systems and connected solutions like truck platooning using cooperative sensing that were not possible before, because you never could get to that robustness or the degree of solution efficiency that could really implement on a real world environment. And obviously then we have a big change in how vehicles are being tested. And this is all about scenario-based testing, and I'll get into this after this slide. And the biggest benefit that we see compared to perhaps the dedicated short range is the non-line of sight. And this is the piece that really, if you were to use in simple terms, allows you to see through walls. I put that as a very simple term. But in terms of vehicles now, your vehicle, and I'm not saying the driver, but I'm also saying the vehicle now has the ability to see beyond its eyes, ears, and nose, and in this case, kind of a supercomputer. But also CV2X brings about, like it does with the 5G, a new idea of decentralization and interoperability. And these are things that previously, again, this cross-industry, automotive, infrastructure, traffic, et cetera, telecommunications have really not, worked together on. And so that's why CV2X has become the front runner in a lot of the vehicle technology, is because it offers the first chance for infrastructure to provide real-time information and the ability for operators to see beyond their line of sight. And I'll go into a little bit more of that today, as well as also cover kind of what we're doing at Innovation Factory and CITM, and the kind of deployments that we're looking. So the biggest thing right now we see is obviously on the automotive side also, and just in general of testing, is how to test connected autonomous vehicles. That is the #1 question that a lot of regulators, certification agencies, safety, advocates, et cetera, are looking at. And traditionally, if you see on the left, vehicle testing has always looked at the vehicle and its systems functions in the environment. So how the vehicle interacts with the environment. But recent innovations like the smarter cars that we see nowadays have been geared towards more safety cases and integrating smartphone functions. Now, what I mean by critical safety cases is, I'll give you an example. This is what I learned from NHTSA, was that the reason a lot that the backup cameras, both the audio and the visual cameras, were implemented and standardized on the vehicles, because a lot of people kept running children over, backing out of the garage. And that was a critical safety case that happened. So that resulted in backup cameras becoming standardized on the product. Similar to now where connected autonomous vehicles is going, a lot of those critical safety cases can be resolved using some technology. And then obviously we've also seen a lot of OEMs try to integrate the smartphone functions with CarPlay and et cetera. And I'm sure a lot of us have opinions about that. But the biggest concern is, previously how vehicle testing has been done is obviously a lot about vehicle dynamics and the sensors with the parts. But the future now has more than just the vehicle's interaction with the environment. The environment can actually interact with the vehicle and perhaps even give guidance, make influences on its decision making, right? And with the introduction of AI, a lot of these algorithms may request further data. And this is why and the automotive industry is going through a change that, in the past 100 years has not seen much difference. But in the next 5 years, we think it's definitely going to change significantly. But again, back to the topic of testing, the reason why, autonomous vehicles has been so hard to get out on the road is because it's very difficult to demonstrate the safety. And this is a report by RAND done in 2016, very famous report. And you could see, they did some research to show what it would take to reach a statistical significance where the autonomous system ADS is smarter than the human, or results in a lower failure or fatality incident than the human driver. And the research reports that it would take about approximately 5 billion miles to demonstrate that there is statistically difference. And you see a lot of the AV developers now talking about how many miles they've driven before they disengage and et cetera. But it's interesting that RAND in this case shows that, with a fleet of 100 autonomous vehicles, and let's say these 100 autonomous vehicles were test driven 24 hours a day, 360 days a year at a very low speed. So it's not a 45 crash test example. This would still take about 518 years. So half a millennium for you to show at least some significance that the system is better than the human driver. So this report states the value that, you can only test so many things in an enclosed environment. There's only so many things you can test on a test track. And that's where places like Innovation Factory, CITM, where you're using both the public and the open road, also geofenced areas, to really help and allow these developers to test those edge cases, those unique scenarios that really you can't replicate on a testing scenario. And then we also think about, when we're driving, right? And I always like to take the analogy of the signs and Google Maps. Those are the two current forms of, let's say, applications on the road, where you see, you know, they're either giving guidance or with the Google Maps or the Waze, for example, they're giving you warnings and routing information, but these are still very static, you know, information, you know, and obviously you see on very congested Los Angeles, right? This mapping only gives you, but doesn't give you guidance further beyond than what is going on, right? And so, and how quick this information is updated, and the fact that these traffic signs are all different across regions, across each state, across each country for that fact, the ability of the driver to, or an ADS system to comprehend all of this would be very, very difficult. And so this is why, you know, applications on the road, there hasn't been any changes in the last 100 years, you know, obviously with Google Maps and Waze, but this has still been very much static. And now with the introduction of V2X, I think a lot of this is going to change and perhaps become more standardized. And then obviously I talked earlier about how a lot of the testing is moving towards scenario-based. This is an example. I have a couple images from some standards groups that we work with, but you can see that each region, like I said before, has its own unique road design, its own traffic management features. The middle picture in the you see with that's in color is an image from one of our partners in Brad Motion, who worked on the US DOT connected vehicle pilots, and this is obviously in Florida and Tampa. And I'll show you a little bit more about why this scenario is interesting, is because when they tested this scenario, they explained to me that actually this is a reversible highway. I've never actually been on a reversible highway or seen one in the fact, but if you see on the left-hand side on the image, you can see that the red, the arrows are going the other direction. So during some times of the day, the highway will flip, and on the left, you'll see that the lanes are closed. And if you're going in from the left on the junction, going in, there's also a stop sign, a very large stop sign, I was told, right in the intersection, right near that entrance, to warn drivers that, hey, you know, this is a reversible highway. But despite the very large sign, drivers are still not noticing this and going in, as you can see by the highlighted yellow of the vehicle. And so what Tampa and the US DOT looked to do was implement V2X to see if they could, you know, impact or influence drivers, push direct warnings and alerts to the drivers to show that, hey, you know, they're going in a wrong section, do not enter, or you're going in a wrong way, and pushing that directly via an HMI to the driver. So these are very interesting scenarios that would be very, very hard to replicate on a testing environment. And obviously, this is the one that I'm sure everybody has experienced before, where you're always trying to beat the yellow, where you're in this dilemma zone where you're deciding, okay, how much time do I have to actually get across that medium in the middle, right? And so this, again, these are all infrastructure that has not had the ability to communicate to the vehicle or the driver. It's always been up to the driver and the human to decide how to proceed. But now that AI and et cetera are being introduced, CV2X is really looking, and a lot of the OEMs in the industry is looking to have perhaps disrupt how driving behavior and the roads are being used. And here's a snapshot of all of the standards. Standards help a lot with you know, unifying a lot of the competition and the technology that is deployed, also making it safe so that everybody, you know, in terms of liability, everybody can find issues or problems as it goes along. But you can see that we're in this transition period, at least in North America. And obviously on the standard sides with 3GPP, we had a big release, and obviously some of the standards have been frozen, but these will be soon, let's say, commercialized in the next stage. But as in terms of messages, you see we have SAEJ 2735 and SAEJ 2945. Those are really on the vehicle-to-vehicle standards. And then you have the RSU 4.1 NTCIP 1202, which are on the roadside and the traffic signal side. But with the current FCC regulation, this is now being transitioned to the new set of standards, SAEJ 3161, IT, which is, again, the vehicle-to-vehicle, and also the ITE 1.0, which is a similar equivalent to the RSU, as well as also security, which you see on the IEEE 1609.2.1. And you see a lot of the applications looking at infotainment, pedestrian warnings, cross intersections, red light violation, for example. And then obviously there's a big topic where V2X plays a significant role in the highly automated driving applications. And then you can see on the bottom right now what we're talking about are two different sides of deployments, and I'll get into those more a little bit later. So the standards are all good, and there's a lot of participation in the plentiful standards that are being created in this space. But I like this slide because it shows you how the standards are used in the V2X, because despite standards saying, technology's requirements, minimum requirements in the field, technology still behaves a little bit differently. And you can, again, use the analogy of smartphones. There are constant issues and smaller problems that result that just are natural, right? And obviously, some of us have seen where, just by going into the Apple Store could resolve some of those problems without actually helping. But this one shows you how the national standards are still perspectives for the vendor. So how the vendor understands those standards and then communicates that is still very different from each vendor to vendor. And so transporting the message, the quality and reliability of the medium, which is a big topic for the environment, for the machine-to-machine communication environment, and also when you're receiving the message. So how the messages are sent, how the messages are received, and then how you decode and encode them are all very different in each company's eyes. So these standards are guidelines, but they don't necessarily justify what actually happens on the road. And this is the piece that right now I think technology has reached a stage, especially in this transportation and mobility, that perhaps standards cannot even keep up with some of the technology development. But fostering an environment that can create, a certification or standard that meets the real world environment is really what is needed in today. So from a practicality standpoint, right? And so I give you a little bit of information for those who aren't familiar with some of the terms and the applications that are mentioned in some of these standards. The most common ones are obviously our BSMs, which are also common in newer vehicles today. And then in standards, they define 17 different messages, 156 data frames, and a lot of data elements. These are basically a dictionary for all the kinds of data that are now able to be pulled through using V2X technology. And obviously you have a lot of the CAN bus data. And then we have obviously the infrastructure side, which are SPAT messages, which we call signal, phase, and timing. These messages refer to a data exchange between the RSU and a traffic signal controller. So if, let's say, a host vehicle were to broadcast its position, then the host vehicle could also send a signal request message or a signal status message to the RSU that is connected to the traffic signal controller that could then give feedback and broadcast that information going forward. On that same let's say line, vehicles can then also translate or broadcast that message to another vehicle as needed. And so these two, BSMs, SPATs, are typically a lot of the applications and the data that we talk about when we're talking about V2X in this current stage. But where the environment, the machine-to-machine environment is going is beyond the simplistic view of just those applications and those data. And this is kind of the core of the discussion today that I've put together, and really also again what we're looking at in Innovation Factory and CITM. But here's a snapshot of kind of the product offerings or the service offerings that we have. Obviously, there's a big emphasis on the cloud management platform where we're working with some local partners. We've also introduced an edge computing that I'll maybe touch on a little bit near the end that really help to facilitate and improve, optimize the network environment. And then obviously we have the terminals, the roadside sensors, right? And you can see we have onboard unit that goes in the vehicle. It's an aftermarket device. There's also the modular level. And then we have the roadside unit and we have various sensors, right? LiDAR, radar, cameras that are both on the vehicle and on the roadside. And then we have a host of applications, a smartphone app using an Android system that can display, an HMI or some warnings, auditory and visual to the operator or the driver. Here's also a little small spec sheet, perhaps, of the technology of the units and the terminals being deployed on the network. And you can see I've highlighted, right, the recent change in the spectrum, where they've given now allocated 30 megahertz instead of previously what we expected was 20 megahertz. And so a lot of I've given you both the cellular V2X and the DSRC specifications in this, but it's either or a dual mode in some instances, and there's still a lot of debate about the dual mode in the industry. And here's the roadside units, the onboard units. Very similar, a little bit unique is that the onboard units also have an IMU, so not necessarily needed to be connected to the network to determine a little position. Also in those weak GPS signal locations, the IMU will help with position accuracy and etc. And obviously you can see we follow the wave specifications for the DSRC, and for the cellular we follow 3GPP release 14. And obviously these devices have been tested, very harsh environments, both humid and harsh cold. And we also have the HMI Android app that is connected with it right here. And I know that some of this is Chinese. This is still being improved and optimized as North America rolls out. But you can see this is a perhaps newer version of a mapping, right, which I previously shown the traffic signs. But this is a little bit more interactive, maybe not so static. And again, what V2X does is now it opens that machine-to-machine communication. So not only the vehicle sensors and all the host of, computing power on it, but also now the road sign, right? If there's dynamic road signs, and even in the future, commercial, non, traffic or vehicle related. It could be things such as like tolling or even, advertisement. Those are all things that are now possible because now V2X has created that environment for machines to communicate. Here's a snapshot of how the intelligent V2X network is going to be built. You can see on the top, we ideally be connected with the traffic management center, and we will be putting out or have already put out the smart cone, which is exactly what the company's name says. It's a new intelligent cone, roadside cone, and it has both camera, radar, a host of various sensors, including environmental particle collection sensors, etc. And we'll be integrating that with the RSU. And obviously on the network side, we'll be looking with some base stations and connecting with the TMCs. And then on the bottom, you can see on the onboard unit, we're obviously looking at passenger vehicles, specialty trucks, heavy duty trucks, logistics, and those are all different ways of accessing perhaps data information or giving warnings to the driver. I've also given here a snapshot of the private test bed near the Innovation Factory. Funny thing is, last year in February was since we started the pandemic, Innovation Factory was the only business travel that I did that year, actually in the past 2 years. And so I did come to visit this, and it's a very interesting environment. You can see on the right, we've already put up some of these intelligent roadside devices, and our connected coverage is roughly about a kilometer. Both short range and long range, PC5 and UU. And for our devices, the chipsets used is Qualcomm. And so in this private test environment, many different applications, and obviously we're close to the McMaster Automotive Research Center. And hopefully this area will become more and more intelligent as we go along. I give you an expanded view of kind of different scenarios, and obviously the operational design domain that I'll talk about a little bit. But you see, the private test bed, the Innovation Factory, and then you see it's right next to some highways and some rails. And those are very interesting applications and use cases for V2X in this environment, and autonomous vehicles for that matter. Here is a snapshot of the smart mobility public test bed, an urban environment perhaps, both residential and commercial. You've seen it highlighted. And we put up 3 roadside units. We'll be looking to integrate them with the traffic signal controllers. These devices are CV2X. But you can see that for cities that are looking to either engage or develop, the expertise around connected autonomous vehicles, a lot of these public test beds provide an opportunity for, both environment to facilitate, how the vehicles are operating and the safety matters, but also for the cities to learn, new business models, because as we've seen in smartphones and the retail sector, data is everything. And like I've said before, previously, the traffic in the automotive have been very static. There hasn't been too much data collection, or at least a centralized data collection. And so the only way for smart cities to think about, leveraging the infrastructure, obviously, because there's only so many roads you can build and so many roads you can expand, and those expansions are very expensive. So the only way to really improve and optimize, reduce traffic, congestion, optimize, improve traffic efficiency is really only by using data. And how you get the data now on the infrastructure is the big piece. And this is why CV2X and V2X in general will play a big role in the future. Here's a short list of some scenarios and applications that can be tested. You obviously have both signalized and unsignalized intersections and T-junctions. You have a pedestrian crosswalk. There's some transit going through this area. There's also some commercial duty. With the industrial and the commercial regions, there's also some heavy duty trucks doing logistics. And obviously we can do things such as like automated delivery of goods. You could also do transit signal priority. And we obviously, a big topic right now is truck platooning. And this is again touching on kind of the topic I mentioned earlier, where a lot of the vehicle testing is moving towards scenario testing. And you can see right here, I've listed some of these scenarios and in the operating design domain. I've also listed out the fire station, which are very interesting applications that we'll be definitely looking to work with. And I go to you right here. And here's what perhaps a solution could result once the V2X is fully enabled. What we call it is green light wave. And obviously people could always imagine this when you're driving, is if you could hit every green light, right? But as it relates to a special use case, right, for the fire station that we've now put up a roadside unit device, the fire truck could then come out and immediately request priority for all the traffic signal, the whole route to where the accident or the incident is taking place. And I'm sure these fire station and fleet owners and operators would love a kind of solution like this, because then it minimizes the safety risk that, by slowing down at the intersections and making sure that there's no one crossing, but also in terms of time to the incident, which is the #1 factor to saving a person's life or not, right? And so these applications are ready to go and deployed. And you can see the significant increase in efficiency by doing such thing, and not only for specialty vehicles, but also for future passenger vehicles as well. We also talk about smart highways. Right, and for example, on the far left, you see a 3D world, very simplistic image. But once you're able to enable V2X in that environment, you could provide warnings and alerts. For example, that there is a congestion, right? When you're entering a tunnel where it's quite dark and you can't see that there's backup, or you can't see, 5, 10 cars ahead of you, V2X could play a big role in providing that warning to warn you to, hey, slow down. Or on the next two set of images you see where it's a merge on, a very interesting use case. Obviously a big topic right now in UNEC and the World Economic Forum, which is automated lane keeping, right? And so merging onto the highway, merging off are all, again, very risky situations. Right now, imagine what if a V2X enabled car passing by an on-ramp, was able to warn, hey, there's a vehicle coming, move aside, right? Whereas, when you're driving, you may not fully pay attention until the last second, which is too late. And so these kinds of scenarios and applications are all being developed, tested, and refined nowadays. And I like this one because it shows you a little bit of a more monitoring method, perhaps, where a lot of the fleet drivers, and we're thinking more specifically for heavy duty trucks. I know there's a big privacy concern when it comes into your own vehicle, but in terms of fleets, right? When we're thinking about safety, drivers have a big, they're very strenuous when they have to drive a certain number of hours during the day. And there are some risks, and I'm sure they would also like safety technology to help, improve their operating. And I'm sure, for example, on the image on the left, right, the video, this is again where the fleet has already implemented a safety measure, safety application, where the driver has to manually have their hand on the wheel, right? Or else the sensors will beep and it'll tell you to slow down, etc. In this case, the driver is actually still having his hand on it, but he's still falling asleep. So there's ways to still go beyond, let's say cheat in those systems. But by implementing further risk monitoring systems like driver monitoring or active safety, these systems, especially like V2X, can really provide risk analysis and reporting for some of these fleet owners. And let me check on time real quick. Good. So I've always talked about standards and industry groups. So I'd like to perhaps end a little bit on some of the industry groups that are playing a lot of influence. One is Omniair in the connected vehicle space, V2X. They've traditionally actually was born from the tolling industry, where obviously V2X has been a very interesting topic to talk about. But they've since, moved very strategically towards ITS, and they're currently very well recognized in both Canada and North America and around the world, in fact, for providing interoperability testing and certification for ITS tolling and connected vehicles. And iSmartways, we are a member, and they consistently do testing and plug fests. And the next one is actually in June 18th in M City. Here's another one, a little bit more on the autonomous vehicle, automated driving system, an alliance called International Alliance for Mobility Testing and Standardization. And you can see a host of members really looking to create a global harmonized, maybe best practices of how to both test and perhaps deploy connected autonomous vehicles with a little bit more of a focus towards highly automated systems. And there is an initiative in this group that is looking at test beds because, again, we view that these test beds play an important role with how scenario-based testing is rolling out now in both open and closed environments. Here's another one, which I previously mentioned is a standard on the roadside. This is a newer sort of committee looking at V2X. It's called ITE. It was previously, this group was the RSU 4.1. And they've now created an implementation or standard that really a simplistic, just a smart intersection. And when I mean a connected intersection, what I mean by a connected intersection is a roadside unit connected to traffic signal controller and simplistic. So nothing too advanced, not including any cameras or lidars or other roadside sensors like we've done at CITM and Innovation Factory with Smart Cone, but a little bit more simplistic for perhaps less progressive traffic management centers that are really looking to leverage existing technology for a low cost, right? And so this is really looking to commercialize V2X on a large scale. And the document and the group, feel free to look out. If you have any questions, feel free to reach out. So CITM and Innovation Factory being a research facility, research testbed, I wanted to outline some of the things that are, what is current also needed. One of the biggest ones is we talk about, right, the interplay and interchange perhaps between traffic, automotive, and telecommunications all merging together, and even more. But the new elements of the infrastructure, right, as electrification happens, charging stations will come out. Could they perhaps replace the gas stations that are now that created the suburban lifestyle that we know it today? Or are there new forms of road users? For example, those e-scooters, the very dangerous electric scooters that are prevalent all over the place, especially in urban environments, and especially during drinking, that really impact driving behavior and also road management. Right now you have scooters laying around everywhere, right? How do you then manage the road with all future new technology, right? And then using the analogy of the smartphone, how will the driving experience change, right? So for example, I like to take the analogy of Tesla, right? Tesla has implemented a host of software applications into the vehicle where you could play games, you could change the sound of the horns, right? So how are these things change then the whole traffic environment? And then obviously the biggest topic I've mentioned here is how to test connect autonomous vehicles. This is the biggest topic that I'm pretty sure not many countries still know, although in the recent couple months, there have been some releases of testing frameworks from various regions, including Germany, US, and China, as well as Japan. But the biggest thing on this one is that a lot of the testing has been stuck to what I would say is a silo. Not many developers have tested in mixed environments. So, for example, a GM Cruise and an Argo AI and a Navia have not been tested in a simultaneous environment yet, nor have they tested in an operating environment. And these are all supercomputers talking to supercomputers that are also taking up bandwidth, taking up latency, et cetera. So how do that then implement an entire network environment once it gets out there? And we haven't got, and it's hard to do that testing because to get up to that capacity is quite an investment. And then obviously a big one is on liability and risk and insurance, right? And now, again, adding in the infrastructure to the vehicle environment. So not only the vehicle's driver's behavior or whether it be UBI, right, how hard you're braking, but now also the ability for infrastructure to influence the risk. How do that all play into determining liability and underwriting, right? And so these are all huge topics, and the list could go on and on as things are going on. But I think these are a lot of the core ones that will really impact the driver and the operators, fleet operators and road users, infrastructure owners and operators as well. And the biggest, I guess, would say is that, the vehicle is becoming more and more smart. I mean, you're having a mountain of intelligent and high fidelity sensors, whether it be cameras, LiDAR, ultrasonic, radar, et cetera. Your vehicle is practically a living, traveling supercomputer. right? And in order for the supercomputer to process and then relay or decode or message or broadcast, your vehicle cannot have any of the things that you see on the computer or the smartphone because you're out on the road. Seconds matter are a lifesaver. You can't have blue screens on your computer. There can't be any lag or low latency, right? You can't have images that stop and then frames that are running kind of like a flip book back in the day, right? No, it has to be high fidelity, high resolution, right? And so in order to do that, then, in addition with all the AI learning methods, the deep learning and the machine learning, your network communication is more important than ever. And perhaps North America hasn't got to that stage because previously they've worked a lot on the dedicated short range, right? And so we're thinking more direct communication, right, V2V. But now as a lot of the standards and the regulation move towards CV2X, and a lot of the testing and operations that we see in a lot of the white papers as well, we see in Asia are all geared towards this future machine-to-machine communication environment. And all of it requires a couple things. One, greater bandwidth, lower latency, ultra reliability, and obviously security. And the biggest thing, obviously, for a city and an infrastructure owner operator is also to think about interoperability. Because each vehicle, again, if you think about it as a silo, they're all different systems, and you as the infrastructure must also be able to have all of those devices and technology communicate. And obviously, there's a big impact if also data can be processed locally. And this is the thing, the last slide that I'll end on is kind of where we see the future going. Last two slides, I guess, is kind of where edge computing and the future of 5G and cloud computing come in play. You see, this is some of the stuff that we've just begun piloting and testing in China, where we're looking at really adaptive control, active management of the infrastructure, right? And something where we call edge as a service or infrastructure as a service for that matter, right? Because now each sensor has various data. That data could then be processed. But in the current method, a lot of that processing takes place at a central database, right? And that results, again, in the latency and the bandwidth. So perhaps in the future, there's a big emphasis for CV2X plus a mobile edge compute, plus the 5G and cloud computing. And so this is just a quick slide shot of some of the future of where the machine-to-machine communication environment is going. I think I've kept on time. Hope I didn't talk too fast. I hope everybody got that too. I hope. But
We're good to go. Thank you. Now, are there any questions at all for Charlie? If so, just plop it into the Q&A, or you can raise your hand. So we'll just give it a few minutes.
I have a couple while we're waiting. Charlie, are there any test environments that you're aware of where compute at the edge is being trialed now?
So very interesting. Now, a lot of the V2X space have just got into this atmosphere, but we've seen a lot of this testing more so in Asia, and definitely more on the test beds in China, for example, are really looking at. But I would say a lot of also the telcos. But in terms of what I've mentioned in this, I'll go to the slide. What I mentioned in edge computing in this one is actually a little bit different from the network edge. This doesn't actually have any communication. It's more of a processing side that will really enhance the environment with the roadside and the traffic signal controller. But so far, we haven't actually seen much of this in North America. Now, we've obviously been advocating for this now, and a lot of the white papers we see coming out of China from the telcos is really geared towards this. So perhaps this year, end of this year, next year, we could begin talking about some of this in North America. And I know I talked a little fast, Richard. I just saw that message.
Yeah, great. Can you go back to the standards slide? Mm-hmm. The one that was like a map. Yeah, so there are 4 standards. What does each of those pertain to?
So the blue one right here, the newer CV2X, and I'll maybe blow this up for you. That's okay. SAEJ 3161. This is a updated standard for CV2X for the SAEJ 294, and that's really about vehicle to vehicle. So For example, a big application that's being talked about right now is electronic emergency brake light warning, EEBL, where you're looking at, can the vehicle, let's say 2, 3, 4 cars ahead, when it activates that emergency brake, could that immediately be transmitted or broadcast to the other vehicles behind you, for example. So it's really looking at, for example, minimum performance requirements, what it encompassing between the broadcasting and the communication, from the vehicle's perspective. I mean, obviously SAE, right? And then ITE, Institute of Transportation Engineers, I think I've got that right. That one is a newer standard of the RSU 4.1. RSU 4.1 was kind of the first standard around DSRC, so V2X integrated with the traffic signal controller. So again, if you just think of a smart or connected intersection, that's really what ITE 1.0 is about. NTCIP 1208 is traffic signal controllers. That's the newer traffic signal controller standard that's fitted towards V2X. So really standardizing and kind of talking about how traffic signal controllers, advanced traffic signal controllers, now can be integrated with the V2X. And then the last one on the far right is IEEE 1609.2.1, which is the newest security standard that many of these standards actually on the right in the blue box have just been released, or draft has been published, perhaps.
Are these data and interoperability standards, or do they specify like communications frequencies and like to what standards of what, I guess is the question. That's
a good question. And a little bit of analogy between Asia's, especially in China, they've actually created an interoperability standard. And so one that's, once every vendor should perform and be able to communicate. But these are more so, from the performance requirements, from the vehicle's perspective, it's still very much separated and siloed. So, and obviously you have the lower radio layer with IEEE 802.11p. So obviously the network side, the MAC layer and the physical layer. So there's obviously that inherent, but below that, but in terms of, let's say, messages and the applications between the V2X and the devices, this is kind of more so, what is being transmitted and what should be required from the standards.
Thanks, John.
I do have a question, and I'll read it out for you, Charlie. So it says, can you speak in terms of the research and who you believe should own/manage the insurance liability risk? Is it producers of the technology, governments, a regulatory body that consists of representation from various stakeholders?
So this is a good question as well. And this is really, I guess we'll wait and see, but I think people have, at least the industry has come to somewhat of a consensus on this. Now, insurance is still looking at it, and I know how complex underwriting can be with the math and et cetera. I've actually also used to work in some financial side of this. But where testing is going will also determine a lot of how they determine the risk. But the biggest piece is, for example, with autonomous vehicles, and I won't use the case of fleets right now because it's not there yet, but let's just say an autonomous vehicle, let's say level 3 or above, right? A lot of people are now talking about teleoperation. So, for example, and it's almost similar to the on-demand model, right? Where the on-demand operators are in a center, and if the driver runs into a incident where they need help, you can push the on-demand and the operator's there to help, right? But that's been, again, with a human to machine kind of way of technology. Right now, the future is more machine to machine. So could you implement, for example, a mobility center, let's call it a mobility center, or in this case, I would say using CITM's language, a multimodal mobility center or integrated mobility center. Then those guys, for example, could control the vehicle, abroad, or even operate the vehicle as needed. And so instead of just a human talking about, hey, what kind of measures you should take, or how to get out of the car in a crash situation, right? So a lot of the insurance also will depend on who owns the vehicle, and that's also a current debate, whether it be the automaker, it could be new companies. right? These are all research areas, potentially areas that need development on. And then it could also be these teleoperating companies. For example, there's one out called Beep, who runs obviously the Navia shuttles and the Easy Mile shuttles, the things. So as insurance is looking at this, and they've been actively looking at it for a long time, a lot of it also will depend on where the business model of the vehicle ownership will go. And a lot of the discussion is obviously on taking that away from the driver and moving it towards the companies. And so it's a very interesting area.
Perfect. I don't see any more questions in the chat or the Q&A. So I'm not sure if you have anything else, Richard?
No, not for this morning. We will do an update to this in the fall as Ontario starts to open up and we can get more activity on the network out of lockdown. I will point out to the people that are attending that in addition to having the ability to do live testing on the network, we just CITM will make the data available in the data repository as well. We're just at the point now where we're about to put on what iSmartways calls the OBU, or onboard units, into several vehicles. So we'll get samples of the data sets that are available from different kinds of vehicles, right, in the data repository. Oh,
and actually, Sean does have a question. So I've given you the opportunity to speak, Sean. So go ahead.
Thank you. The value creation utilizing V2X technology is the key in terms of daily use applications. So I'm just wondering, what is the future roadmap of iSmartways for, like user friendly sort of like technology and service, like in service in areas?
That's a good question. Sean, it's very late for you. Thank you for staying. I will show you this one slide. Sorry. So if I have your question, you're asking about where the applications, right? The future roadmap for the applications?
Right.
So now in this slide, I've kind of shown you, especially on the bottom end and the top on the cloud. A lot of what I've mentioned here is on the operational platforms, right on the top level on the cloud. We were talking about more regional side, and on the bottom you could see the basic applications, right, that we've seen all seen from the industry. But as this environment changes, when you introduce mobile edge compute, when you introduce 5G, when you introduce more cloud integration, a lot of this then translates to the network side, right? And obviously quality of service, but also it brings into new ways for decentralization and active management. So a lot of things we could also talk about: active traffic signal control, where it'd be, active and adaptive traffic signal control, where the traffic signal could think for themselves, right? Because you've now implemented both the processing local and what we say the MEC next to the RSU that can then process some of that. It doesn't have to necessarily go back to the center and then immediately translate. So that really creates what I'm like, again, the topic of my talk was the machine to machine. And then previously, again, if you take the example of on demand, it's been human to machine. It's never been that the machine is now giving input to another machine and the machine then has to process it. So that opens up a host of things where the human is not involved. And so those applications could get very interesting. And if you just think of the future, right, active traffic management, road management, it could be then, another thing was what we call is digital work zones. Could you then implement, not physically putting out traffic cones, but in a virtual environment that the vehicle sees that, okay, this lane is shut off, or this lane is reserved for traffic or fleets, or there's a reserved for taxis, for example. So those are the kinds of things that we see the future kind of going towards.
Thank you. Thank you, Charlie.
all right, we are coming up on time. Charlie, I wanted to say thank you for today. This was a great presentation, great summary of the content and of the use cases It kind of makes me think back to the early days of GPS, where you put GPS up and no one really thought about the applications that were available. And all of a sudden you have an Uber and Lyft that leverage that kind of, as well as hundreds of others applications now. So
yeah, and I give you another one. I don't know if you've heard of Nextdoor or Neighbors now, and all this stuff is becoming more and more integrated. So, GPS mapping, and then you had Waze, right? And now your user can give input, right?
Yeah.
And that then communicates to this. So it's very interesting. Agree. Thank you for the opportunity, though. I also see we have another question.
Oh. Do we have another question, Greta?
We do not, I apologize.
That was Vivisha's question from earlier.
Yes.
Oh, okay. Sorry.
All right. So thank you very much. Again, we will make this, Charlie has said, yes, we can share the presentation as well as the recording. So in due course, those will be available on the CITM website, as well as when they're up, we will post them on via LinkedIn and Twitter. For those that attended today, I'd like to thank you all for attending, for your time and attention. And again, Charlie, again, a big thank you to you. Right? I look forward to the day we can meet in person finally. Thanks.
Pleasure. Thank you so much.
Okay. Thanks, Greta. Bye now.